Hello student, today we will discuss about the inverse trigonometric function. Okay. So, start with inverse trigonometric function. Inverse trigonometric function. Okay. So, for already we are knowing about how inverse of function will exist. Okay. So, for existence of inverse of function, function should be bijective. Okay. That is, if function is 1 1 and onto, then their inverse will be exist. So, in same way for trigonometric function also we have to, if any bijective function has given, then their inverse will be exist. So, let us see for inverse trigonometric ratios, their inverse are existing or not existing. Okay. So, for sin x, the domain is real number and range we are getting here -1 and 1. Okay. So, sin x is defining from real number to -1 1. Okay. So, that means if you check onto function, so this is onto because for all value of minus, that is between -1 and plus 1, their pre-image are existing. Okay. But if you take here, that is for many value of real numbers have a same image in close interval -1 1. So, this is many one function, not 1 1. So, that is why this function is not a bijective. Okay. So, for existence of inverse of function, okay, that means function should be bijective. So, we have to take a interval in which function are bijective. So, sine, that means if you are taking the interval like minus pi by 2 and plus pi by 2 and the range is -1 and 1. In that case, their inverse will be exist. Okay. So, that means in minus pi by 2 to plus pi by 2, sine is invertible. Okay. Same way for all trigonometric ratios, we have to take their restricted domain in which function are bijective, and if function are bijective, then their inverse will be exist. Okay. So, start with the definition of inverse of function again. How will define inverse of function? If f is a function from a to b, f is a function from a to b is bijective. Okay, f is a function from a to b is bijective. Then the inverse of f, that means g we can consider, or f inverse is a function from b to a is the inverse of f. Okay. And suppose that if you are taking x element in diagram, by diagram also we can understand inverse of function. So, I am taking two set a and b, and by f rule a set a linked with the set b. Okay. And x which is belonging to set a and f of x belonging to set b by f rule. Now, if you are taking inverse of f inverse, so that means f of x, what is your y? So, when we apply f inverse rule on y element, then we will get here x. So, f inverse y is equal to x. Okay. So, by diagram also we can understand by f rule x linked with the y, and by f inverse rule y linked with the x. Okay. So, f inverse is a function from b to a is the inverse of f such that y is equal to f of x, and this implies that f inverse y is equal to x. Okay. So, suppose that if you want to find, if you are combining two functions like f of f inverse. Okay. So, f of f inverse what will be? So, f inverse domain what is that means y is belonging to set b. So, we can apply f of f inverse on y, then we will get here f of f inverse y. Okay. So, f inverse y what is here? F inverse y is x. So, on the place of f inverse of y we can write here x. So, f of x, and already we are knowing that f of x is equal to y. Okay. So, f of f inverse of y is equal to y. Okay. Same way, if you are taking the composition of function like f inverse of f, so domain of f is set a and x belonging to set a. So, we have to apply this composition of function on x element, and we will get here f inverse of f of x, and f of x what is your y. So, f inverse of y and f inverse y what is here? F inverse y is x. Okay. So, composition of inverse of f will be x. Okay. Now, by this rule we have to find the inverse of trigonometric function. Okay. So, firstly we will decide their domain in which function are invertible, and after that we will discuss their graph and some question related to inverse trigonometric function. Okay. So, start with the domain in which function in trigonometric ratio will be the bijective. So, start with the sine inverse. Okay, so sine function is invertible in minus pi by 2 and plus pi by 2 to minus 1 and 1. Okay. Now, if you are taking the inverse, first of all just we have tried the sine domain and range in which function are invertible, and after that we have tried the inverse of the function. So, cos is invertible in interval 0 and pi, and the value will be minus 1 to 1, and tan, the interval will be minus pi by 2 to plus pi by 2, and the value will be real number. Okay. And cot 0 to pi, okay, and the value will be real number. Sec is defining from, that means cos is defining from 0 to pi, that means in case of sec, so sec 90 is, that means if you will take cos 90, so cos 90 is 0. Okay. So, when you are taking sec 90, that means sec 90 will be 1 upon cos 90, that means function will not exist. So, 1 point we will get here, function will not exist. So, we have to minus here 0 pi minus pi by 2, okay, where sec function will be exist, and the range will be r minus 1 and 1. Okay. We can write also here minus infinity to minus 1, okay, union 1 to infinity. Okay. Next one, cosec is defining. So, cosec is 1 by sine. So, sine, that means minus pi by 2 plus pi 2. So, cosec in where cosec will not exist, like suppose that if you are taking 0, so sine 0 is 0. So, cosec 0 will be 1 upon sine 0, that means infinity form you will get, that means cosec will not define at 0 between minus pi by 2 and plus pi by 2. So, we have to minus here, in which cosec will be defined, and the same range will be r minus 1 1, okay, r minus infinity minus 1 union 1 infinity. Okay. So, these are 6 trigonometric ratio, and in their restricted domain function will be invertible, that means function are 1 1 and on 2. Okay. Now, their inverse also we can write in domain of inverse, like suppose that if a function f from a to b, so their inverse is a function from b to a. So, we have to reverse their domain and range. So, that means we can write here domain of sine inverse, in which function will be exist. The sine inverse what will be minus 1 to minus pi by 2 to plus pi by 2 in closed interval. Okay. And for cos, so cos inverse, that means minus 1 to 0 pi. Okay. And for tan inverse, so tan inverse will define, that means from real number to minus pi by 2 to plus pi by 2 open interval. And for cot inverse, that means cot inverse is defining from real number to 0 to pi. Okay. And same way sec inverse we can define here, sec inverse is defining from r minus 1 to 0 pi, okay, and minus pi by 2. And cosec inverse finally, so cosec inverse is defining from r minus 1 to minus pi by 2 to plus pi by 2 minus 0. Okay. So, these are restricted domain of sine, cos, tan, cot, sec, cosec, and their inverse is defining from minus 1, 1. This is very important point. If you remember all these points, then we can easily solve the question related to inverse trigonometric function. Okay. So, we have to keep in mind what is the domain of sine inverse, what is the domain of cos inverse, what is the domain of tan, cot, sec, cosec, and their range also. Okay. So, according to that, we can solve the many question on the basis of their domain and range. Okay. That is inequality questions also based on their domain and range. That means, if you are solving cos inverse x greater than 0, so we have to find the value of x which is belonging to domain of cos inverse. Okay. So, we have to learn all these points by anyways. Okay. That is their restricted, that means their pattern is also here. Okay. If you are knowing the domain and range of sine, cos, tan, cot, sec, cosec, then only just we have to reverse here. Okay. This function will be bijective. Okay. Now, we start with the graph of sine inverse, cos inverse, tan inverse, cot inverse. So, start with the graph. Okay. So, graph of sine inverse. Start with the graph of sine inverse in which function are invertible. That means, just only we have to take the restricted domain in which function are invertible. So, for sine, okay, first of all we have to make the graph of sine. Sine is defining from, that is minus pi by 2 to plus pi by 2, and the range is minus 1 and 1. Okay. Now, let us make the graph of sine, and after that we will make the graph of sine inverse, okay, by understanding the graph of sine. Okay, this is x axis and this is y axis, x and y. Okay, generally first of all we have to represent x axis, that is x axis angle we have to represent on x axis. So, this I am taking here, this is pi by 2, okay, and this is minus pi by 2, and this is plus 1 and this is minus 1. Okay. So, maximum value what is here, plus 1, and minimum value is minus 1. So, sine 0 is equal to 0 and sine 90 is equal to 1. That means, this is a point where last point we will get in this interval. So, like that we will get the graph. Okay. And sine minus pi by 2 equal to minus 1. That means, below this line we will get the graph. Okay, this is a graph of sine. Now, for graph of sine inverse, so sine inverse is defining from minus 1, 1, 2, minus pi by 2 to plus pi by 2. Okay. So, let us see what the graph of sine inverse. So, we can make the graph here like that. Okay, this is x, y. Okay, now we have to represent, that means in sine just I have taken minus pi by 2 plus pi by 2 on x axis. Now, here we have to take minus pi by 2 plus pi by 2 on y axis, and minus 1, 1 on x axis. So, this is minus 1 and this is plus 1 and this is plus pi by 2 and this is minus pi by 2. Okay. So, if sine 0 is equal to 0 and the value of cos sine pi by 2 will be 1, that means here we will get the point like that, we will get the point, this is okay. And now, if minus pi by 2 we are taking here, so minus pi by 2 will be minus 1. So, we will get the graph like that. We can write also their coordinate. Okay, these are points. So, this is the coordinate is 1 and pi by 2, and this coordinate is minus 1 and minus pi by 2, and here is the coordinate pi by 2 and 1, and this is the coordinate minus pi by 2 and minus 1. Okay. So, this is a graph of sine and sine inverse. Okay. Now, let us see the graph of cos and cos inverse. A graph of cos and cos inverse. So, cos is defining from 0 to pi, okay, to minus 1 and 1. So, just represent the angle on x axis 0, pi by 2, and this is pi, and value here is a plus 1 and this is minus 1. Okay. So, cos 0 what is it? Cos 0 is 1, that means we have to start from that point, okay, and cos 90 is 0. So, cos 90 is 0 and cos pi is minus 1. So, we will get that like that graph. Okay. So, this is the coordinate here pi minus 1 and this is the coordinate, starting coordinate here is 0 and 1 and that point is x is 0, sorry, x is pi by 2 and y is 0. Okay. Now, for cos inverse, so cos inverse will define from minus 1, 1 to 0 to pi. Okay. So, let us see the graph of cos inverse. Okay. So, for cos inverse we can represent here this is x axis, y axis. Now, angle we have to take on y axis and value, that means plus 1 and minus 1 on x axis. So, this is 0, pi by 2 and this is pi and this is plus 1 and this is minus 1. Now, minus 1, that means we have to start here, cos 0 is equal, that is from that point we have to start from plus 1 and this graph will go like that and minus 1 point is here. So, we have to represent this minus 1 point and it will move cross like cross to pi by 2 and in width at 1. Okay. So, coordinate of end point what is this is 1 and x is 1 and y is 0 and here x is 0 and y is pi by 2 and here what is x? X is minus 1 and y is pi. Okay. So, this is a graph of cos inverse. The same way we will discuss the graph of tan, sec, cosec and the chord in next video. Okay. So, first of all we have to remember all the domain, range and range of all the inverse trigonometric functions sine, cos, tan, and after that we can make the graph and suppose that if any inequalities question has given or any inverse trigonometric question has given. So, the domain and range we have to use in that question, according to that we have to find the value. So, very important here domain and range of all the inverse trigonometric function. Okay. So, thank you class. In next video we will discuss about some more domain.